The Query Optimizer Registry is a subsystem responsible for maintaining and applying cost-based optimization rules to incoming database queries. The registry operates as a stateless catalog of rewrite rules indexed by query pattern signatures. Each rule contains a pattern matcher, a transformation function, and an associated cost model. Rules are loaded from configuration at initialization and persist for the duration of the process lifetime. Rule registration occurs through the register rule method. This method accepts a rule identifier string, a pattern definition in AST form, and a transformation closure. The method validates that no duplicate identifier exists in the current registry state. Upon successful validation, the rule is indexed by its pattern signature using a normalized hash of the AST structure. The method returns immediately without spawning background threads. Pattern matching is performed using depth-first traversal of the query AST. The matcher algorithm maintains a work queue of nodes to process. Each node in the work queue is tested against one or more rule patterns in sequence. Matching is deterministic and order-independent due to pattern normalization. When a match is found, the corresponding rule identifier is recorded and matching continues for lower precedence rules. Cost estimation utilizes a pluggable cost model interface. Each rule maintains an optional cost estimator function that accepts a transformed query subtree and returns a numeric cost value. The default cost model assigns unit cost to each relational operation. Custom cost models may incorporate statistics such as row counts, cardinality estimates, or index availability. Cost models are invoked lazily only when cost comparison is required. The rule application phase processes matched rules in order of increasing estimated cost. For each matched rule, the transformation closure is invoked with the current query subtree and the rule context object as parameters. The closure returns a new query subtree or null if transformation is not applicable. If null is returned, the next rule in the match sequence is evaluated. Otherwise, the new subtree becomes the current working state. Rule precedence is determined by a priority value specified during registration. Rules with lower numeric priority values are evaluated first during matching. Precedence is fixed at registration time and cannot be modified. When multiple rules match a query subtree with equal priority, they are evaluated in insertion order. The registry maintains an internal sorted index of rules by priority for efficient lookup. The constraint validation system ensures that applied transformations maintain semantic correctness of the original query. Constraints are registered per rule and define conditions that must hold after transformation. Common constraints include projection compatibility checks and join ordering restrictions. Constraint validation occurs synchronously immediately after each transformation. If validation fails, the transformation is rolled back and the next matching rule is attempted. Statistic collection is an optional feature controlled by the Enable Statistics flag in the registry configuration. When enabled, the registry maintains counters for rule applications, transformation attempts, and cost improvements achieved. Statistics are accumulated in process memory and are not persisted between process restarts. Statistic updates occur inline during rule matching without separate threads or locks. Configuration loading occurs once at initialization from a YAML file specified by the config path parameter. The configuration structure defines rule sets, cost models, and validation constraints. Parsing follows standard YAML semantics with strict type checking. Invalid configuration entries cause initialization failure with detailed error messages. Configuration validation does not support dynamic reloading after the registry becomes operational. Memory management in the registry uses reference counting for rule objects and transformation results. When a rule is removed via onRegister rule, its reference count is decremented. If the reference count reaches 0 and no active transformations reference the rule object is deallocated. Transformation results remain in memory until explicitly discarded or replaced by subsequent transformations. Error handling in the registry follows fail-safe semantics. If a rule pattern cannot be parsed, the rule is skipped and a warning is logged. If a transformation closure throws an exception, the exception is caught and the transformation is abandoned. If cost estimation fails, cost comparison is skipped and all candidates are treated as equal cost. Query processing continues regardless of individual rule failures. The caching layer maintains a least recently used cache of previously optimized query plans. Cache entries are indexed by normalized query signature. Cache lookups occur before pattern matching. If a cache hit occurs, the cached optimization result is returned without invoking the matching or transformation pipeline. Cache eviction occurs when the cache size exceeds max cache entries. Thread safety is not guaranteed by the registry itself. When the registry is accessed by multiple threads, external synchronization must be provided. The registry contains no internal locks or atomic operations. Concurrent access to the same registry instance without synchronization results in undefined behavior. Registry instances may be safely instantiated once per thread. Performance characteristics depend on the number of registered rules and pattern complexity. Pattern matching time grows linearly with rule count in the worst case. Typical pattern matching time is logarithmic with respect to rules due to indexed lookup. Transformation execution time depends on the specific rule implementation. The registry does not provide built-in performance profiling. Debugging support includes optional query plan logging. When debug logging is enabled, the registry writes human-readable representations of query plans at each transformation step to a specified output stream. Log output includes rule identifiers, cost values, and constraint validation results. Logging imposes minor performance overhead but does not affect correctness. Log output format is unstructured text. Lifecycle management requires explicit instantiation and shutdown. The registry constructor accepts configuration parameters and initializes internal data structures. The shutdown method flushes any pending statistics, clears the cache, and unregisters all rules. After shutdown is called, further method invocations are permitted but operate on an empty rule set. No destructor side effects occur upon object deletion.